Hello students, welcome to the lecture series of IGCSE Physics. Today we will be starting a new topic, resistance. Let us start with a small concept building slide. Let us assume that this is a track on which an athlete will be running. Since there was no hurdles, he was moving freely without any problem. Let us consider the second situation in which the same athlete will be running from the same track from A to B, but there will be few hurdles that will be stopping him to move, or that will be producing an opposition. Similarly, when you compare this athlete with the current and the hurdles with the resistance, you will find that when the current flows through a circuit, the resistance provides an opposition to the flow of the current. So let us define the resistance. Resistance is the opposition that a substance offers to the flow of electric current. It is generally represented by a capital R. Its standard unit is ohm, and it is symbolized or written as in this way. It is generally denoted by a square box in a circuit. Sometimes this resistance can also be denoted in this way. Don't worry, if you will be seeing a good diagram of this one. The mathematical expression of resistance is given by V equals to IR, where V equals to potential difference, I equals to current, and R equals to resistance. Now let me tell you one thing, that this formula is given by Ohm's law. This Ohm's law generally deals with the potential difference and the current, but I am not discussing this part in this lecture because I have already done this part in my previous lecture. Now see, whenever we talk about resistance, we say that it has a unit of ohm. So you have to define 1 ohm. Now how will you define? Let us see. V equals to IR. Now assume that the value of the current through a circuit is 1 ampere. Consider this circuit where the current of 1 ampere is flowing. Now the voltage across these 2 points, let it be A and let it be point B, is 1 volt. That is V A B equals to 1 volt. Now remember, whenever there will be a component, the component can be anything, a resistor, a lamp, or any electrical equipment that is connected to a circuit. Okay, so the potential difference across the point A and B is 1 volt. Now current 1 ampere, volt 1 ampere, so resistance will be how much? We can write R equals to V by I. So ultimately 1 by 1 will give the value of R as 1 ohm. So now see how they have defined. When an electric current of 1 ampere, that is this part, passes through a component, that is this component. See, in this case 1 ampere of current is passing through this component, passes through a component across which a potential difference of 1 volt exists. We have assumed that the potential difference across these 2 points is 1 volt. Then the resistance of that component is 1 ohm. Ultimately, you have to remember, whenever a current of 1 ampere passes through a component having voltage across that point as 1 volt, we call it 1 ohm. See, from the examination point of view, this part is not that important, but the definition of the resistance is very important. The formula is very important, and you will be getting numericals on this formula only. Now resistance in circuit. Most of the time, I've already said they will be denoting resistance or resistor by using this symbol. In IGCSE, I have seen many times they are using these symbols, but they might also use this symbol because many books they denote resistance using this one. So you remember the resistance can be denoted by either this or this. Now this is a circuit. Now this is a circuit having a resistance R, a battery of 12 volt, and current I is drawn through this battery. Remember, the current flows from always positive to negative, and the bigger terminal is always positive and the smaller terminal is always negative. So the current will be flowing from positive to negative. Now as we have seen in the previous slide that whenever current flows through a resistor, it offers resistance to the flow of the current. Remember this one, students. Resistance always offer opposition to the flow of the current. Moving on to the next slide. Resistors combination. In your syllabus there are two types of resistors combination. One is series and the other one will be parallel, that we will be discussing in our next class. So concentrate on series part. See, this is the way the resistors are connected in series. See here, whenever they say कि resistance has been connected in series, means the resistors are connected end to end. See, the end of this one is connected with this one is connected with this one. Understood? Now see, let us go to the depth of this part. How will you determine whether the resistance are in series or parallel? We will not talk about parallel right now. We will be talking only about the series part. How to see? See, if you assume that this is a pipeline, and water is flowing through it. Let us put some resistors here. Now see, if I allow water to flow through it, water will be flowing, same water will be flowing through this resistor. Again, same water will be flowing through these resistors also. So whenever we see a condition where same amount of water is flowing through this different resistor, then these different resistors are always connected in series. Now see, in this case, if you compare water with the current, always remember when there is same amount of current flowing through the resistors, they are always connected in series. Now see, in this one, I amount of current flows through R1. Similarly, again I amount of current flows through R2. Again I amount of current flows through R3. So I think the concept is clear. Whenever the same amount of current is flowing through the resistors, they are connected in series. Now let us consider a situation where the current is flowing through different resistors. In this case, if I suppose that current is flowing in this way, now till this point this will be I, but at this junction this I will be divided into two parts in the same manner as the water gets divided. Like if this is a pipe, the water comes, some amount will go in this direction, some amount will go in this direction. Similarly, some amount will current, let it be I1 is going in this direction, and let in this direction came I2. Now we are seeing that the current through each resistance is different. That means this resistance or this combination is not in series. Now let us derive the formula for the series connection. But there is a thing that this says in series connection, current remains same, but voltage across each resistor is different. First of all, let us see one thing, that voltage across each resistor means what? See, this is a resistor we will take voltage at these 2 points. Again, this is the resistor. We will take voltage across these 2 points, again across these 2 points. So ultimately, we can divide this line into 3 parts. One is this one, second one is this one, third one is this one. So according to this, they are saying the current, let it be I. Same I will be here also, same I will be here also, same I will be here also. But the voltage, that is V, will be divided into V1, V2 and V3. Now how? Let us answer this how. First see, this is a track on which this athlete will be running. In the previous case it was running. In this case, if I put one hurdle, second hurdle, then what will happen? He will have to jump, again he will jump, and then he will reach point B. See, in first case, in the first slide, what we saw, that the athlete was running without any problem, freely he was running. He was not getting any problem, he was not getting any obstacle. But in this case, what I have done, I have put some obstacle, because of which this has to jump from this point to here, again this point to this point, because of which he has lost or he has done some work, and in doing some work he has lost some energy. Okay, now this change in energy from point A, let it be C and B, change in energy from A to C, we call a potential difference of VAC when we are talking about electric current. Against B to C, it will be VCB. Now let me tell you one thing, that potential difference is defined as the amount of work done in moving a point charge from one point to another point. For example, this is a point A and this is your point B. Now I want to move a charge Q from A to B. So for moving it, I need some work, I have to do some work, and that amount of work, let it AB, is 1 joule. I am assuming it is 1 joule. So this 1 joule will be the potential difference. Understood? So athlete equals to current. The track is covered by the same person, A to B and B to C. But hurdles equals to resistance. These are the resistance. So whenever he come across some resistance, the energy is changed. Hence voltage will also change. We are comparing the real life situation with the electrical circuits. Now formula for series connection. This is the resistance circuit that we have discussed earlier. This was the thing that we have described recently. Now see, the total voltage equals to sum of voltage through each resistor. Now see, when the athlete was running, he was full of energy. After jumping one hurdle, again he jumped another hurdle. The total amount energy he took, or total amount of work he did, was taken from the full energy that he was having initially. Similarly, when the current flows or when there is a voltage change, this voltage will be taken from this part. Again, this voltage will also be taken from this part. Again, this voltage will also be taken from this part. Then obviously the sum of this V1, V2 and V3 should be equal to this one, because the total amount of energy is V, and to cross this one, this energy will be utilized. So to come across this one, V1 was this, V1, V2 and V3. So we can write total amount of energy V1 equals to V1 plus V2 plus V3. Now if you assume that if this is the total voltage or total energy, can I write the formula V equals to total current into total resistance? We are saying, I'm assuming that R is the total equivalent resistance of R1, R2 and R3. That is, if I replace all these three resistors with a single resistor R, it will show the same effect as this 3 are showing. I have converted this diagram into this manner. So V equals to IR, but V1 equals to how much? The same I was flowing through it. So I into R1. Again same I into R2 and I into R3. We have written it here. The formula, just recap the formula, V equals to IR. Just we have changed the resistors because the current through R1 is I, so it will become V1 equals to IR1, V2 equals to IR2 and V3 equals to IR3. Ultimately we are seeing that the I is common around here. So what we can do is we can cancel out this R taking common. So ultimate formula will be R equals to R1 plus R2 plus R3. Mark this formula as very important. The reason being that you will be getting few questions in paper 1 from here, that is MCQ. You will be getting questions from this formula, so learn it by heart. If you move on to the next slide, we will see that in the previous question it was only 3 resistors, that is 1, 2 and 3. In the next, if you get n resistors, then the formula will be R equals to R1 plus R2 plus R3 plus R4 plus R5 plus Rn. That means you will be adding all the resistance that are in series. Let me remind you or recapitulate that when the same amount of current is flowing through say different resistors, then these resistors are connected in series. If the current differs, means they are not connected in series. Just remember this logic and you will be able to solve any numerical on series combination. Now question. Now see, in this question what we are saying that, let me complete this circuit for you so that it will be easy for you to understand. Now let us assume that this is the circuit. Okay, this is the positive terminal because the bigger one, the smaller one will become the negative terminal. They have told that the total voltage is 9 volts. So can I write here 9 volt because the cell is having an EMF or a voltage of 9 volt. Now see, when 1 milliampere of current is flowing through R1, R2, R3, it is causing a voltage potential difference of 1 volt, 2 volt and 6 volt respectively. So what you will be doing is, first you have to determine whether these resistors are in series or not. Let's just check. 1 milliampere is flowing through this one. Again 1 milliampere will come here and it will be going through this one. Again 1 milliampere will come here and again it will be flowing through this one. Means the same amount of current is flowing through each resistor. That means these resistors are in series. Or what we can do is, just we will use a small basic, that I have drawn a pipe through which water is flowing. I have put R1 here, that is equals to 1 kilo ohm, R2 2 kilo ohm and R3. Now when the water flows, assume that these resistors are just nets through which water can pass easily. Now what is happening? Same water will flow through this one. Again the same water will flow through this one. Again the same water will flow through this one. This means this all three are in series. If the same water would have not flown, then these resistors were not in series. So now let us solve this question. Now we came to know that the resistance are connected in series. So let us consider the total resistance is R. The formula for series is R1 plus R2 plus R3. So ultimately your answer will be 1 plus 2 plus 6. Don't forget to write kilo ohm. So ultimately your answer will be 6 plus 2 8, 8 plus 1 9. That is 9 kilo ohm. Now see, what does this kilo ohm means? 1 kilo ohm is equals to 1000 ohm. You can compare it with 1 kg, that is equals to 1000 gram. So remember, whenever we add a kilo in front of any SI unit, it becomes 1000. Moving on to the next question. Oh, this looks a little bit typical, but is it? No. Just use the previous concept. This current will be flowing from positive to negative. I have drawn a current I. Now see, there is no branching here, so the current will grow from here and it will move in this direction. Again I assume this is the net. Again the current will pass through it. Again I, again the same current will be passing through it. Again I, again same current I, and the last one also same current, that is again I. What does this mean? That the same current is flowing through this resistor, this resistor, this resistor and this resistor. Now let us compare this one with the water and pipe thing. If you assume that this is the square pipe, okay, I have drawn the same circuit, but a second line I have drawn. Now what will happen? The water will start from here, it will go in this direction, it will go in this direction, it will go in this direction. So whatever you put it here, it will, the same amount of water will be passing through it. So again what we are observing, that this circuit or the resistance in this circuit are connected in series. So what we can do is, again we will write our previous formula. R equals to 65 plus 84 plus 73 plus 10, and in bracket I will be putting ohms. So can you solve it for me? Just try it and put the correct answer. The answer should be 232 ohm. Am I correct? Just check it and tell. Moving on to the next slide, what we'll be seeing is next topic. Resistance in parallel will be dealt in next class. Hope you have enjoyed this class and you have understood